right, so number 18 here, they want a standard form, which we call vertex form, and the vertex and x and y intercepts. I'll go ahead and start off with the vertex here. So I'm going to do negative b over 2a. So that's negative 12 over 12, so that would be negative 1. And then the y value, we can plug that in. All right, and we'll go ahead and solve that. So 6 times 1 minus 12 minus 5. And so that's going to be, let's see, negative 6 minus 5 is negative 11. So we know the vertex is negative 1 comma negative 11. And with that, we can write it in vertex form. So we could do y equals, and remember we steal the a value from the beginning, and we plug in our h and our k. All right, next up, we got to find our intercept. So for the y-intercept, we can just go ahead and look at our c value. So it'll be 0 comma negative 5. Our x-intercepts, we need to plug in 0 for y, and we need to solve that. So I'm going to go ahead and try to factor this. So I'm going to think of two numbers and multiply to negative 30 and add to 12. Let's see, what multiplies make 30? Do 15 and 2, but that doesn't work. Okay, 10 and 3, and that doesn't work either. So it looks like this is not factorable. So I'm going to jump into the quadratic formula instead. So we'll say x equals negative b plus or minus the square root of b squared minus 4ac. That's all over 2a. So x will equal there negative 12 plus or minus the square root of. And back here I have, let's see, 5 times 6 is 30, times 4 is 120. So 144 plus 120 would be 264. That's all over 12. Now we're not allowed to reduce yet because we need to break down rad 265 or 264. So I know that that's even, so it can divide by 2, and it'll be 132, which is even again. So it'll break down as 2 and 66, which is even again. So it'll be 2 and 33, which should be 3 and 11. So it looks like the only kind of twins I have here are these twos right here. As my son says bye to no one in particular. All right, and then so the 2 will go outside, and inside we're going to have to multiply all of these loners here. So that'll be 66 all over 12. So now we can reduce these all together. So I get negative 6 plus or minus the square root of 66 all over 6. So that would be my answer right there. So then on the graph here, I would just say a real quick sketch would draw the vertex and then just have it opening up like that. Would be good enough. All right, these ones are asking just for the... And so that's really just asking for the y value of the vertex. I already know that since this one is opening down, that the vertex is a max. So I'm just going to find that max. So I'm going to do x equals negative b over 2a. So it's going to be negative 2 over 2 times negative 1/3. And so I would simplify the bottom first. And so that's going to be negative 2 over negative 2/3. And then we'll go ahead and multiply by the reciprocal there. So that's times negative 3 over 2. So we can cancel those out, and we get our x as a positive 3. So now we want to plug that back in to find y. So that's going to be negative, and then we got 3 squared over 3, plus 2 times 3 plus 7. So I need to do my PEMDAS here, so it's negative 9 over 3 plus 6 plus 7, negative 3 plus 13, so that's going to come out to positive 10. So my vertex is 3, 10, so I know my max value is just the y value there of 10. All right, 38 here, I need to find the max value. I see that this is not really in any form. It's not vertex form, but it's not standard form. So I would just distribute here to get it in standard form. And then I would find the vertex. So negative b over 2a, 8 over 4 is 2. And then we would plug that back in. So we get y equals 2 times 4 is 8 minus 16 plus 7. So y equals negative 1. I see that a is positive, so I know then it's a min value of negative 1. All right, next up we're wanting to find the function whose graph is a parabola going through, or with the vertex here and going through that point. I would always set this up in vertex form. So I would put a times x minus 3 squared plus 4. And then I don't know a, so I would use this other point to plug in to find a. I'm plugging in x for x and y for y. So negative a equals a times negative 2 squared plus 4. And so negative 8 equals 4a plus 4. Subtract the 4. And 4a equals negative 12. And then divide by 4. And a equals negative 3. So I would say y equals negative 3 times x minus 3 squared plus 4. If you need it in standard form, you could expand that by writing twice and foiling it, distributing the negative 3 and combining like terms. All right, domain and range. We kind of always know that the domain on all quadratics is negative infinity to infinity. The range, however, is kind of dependent on the vertex, so I do need to find that. So x equals negative b over 2a, so that's 1. And y equals 1 squared times 2 minus 2 times 1 minus 3. I mean y equals 1 minus 2 minus 3, which would be negative 4. And so if you kind of visualize this as an upward facing parabola, and then the vertex is 1 comma negative 4, I would say then that the range would be from negative 4 to infinity. So if it has a min, it's going to be from that y value, from that min to infinity. If it has a max, it's going to be from negative infinity to that max. All right, next up here, we're going to find all the local maximum and minimums. So I kind of think that these go down, up and down forever, so I'm not going to find any there. But the local maxes are just kind of the tops of each of the hills. So I got 2 of them here. One of them is at negative 2 comma 2, and then the other one is at 2 comma 1. You can see that those are kind of higher than the points around them. And then the local min, I only have 1, would be right there at 0 comma negative 1. All right, next up here, the soft drink vendor has this formula here. He wants his max profit per day and how many cans must he sell. So we know that x is cans, so I would just find the x value of the vertex first, and that'll answer kind of the second question. So this will be negative 3 over negative 0.002. And we can definitely use a calculator for that one. So when I type that in, I get 1,500 cans. So if he sells 1,500 cans, he's going to reach his max profit. So that's kind of that part. And then for the other part of what is his actual max profit, you can see that that's really the y value. So I do need to plug this in. So negative 0.001 times 1,500 squared plus 3 times 1,500 minus 1,800. And so I would just type this all in the calculator. And you get 450, so that would mean that his max profit for the day would be $450 if he sells 1,500 cans.